Okay, this is third in the series of 3 podcasts for Bio 244 lab activity number 1. This is the data that we collected, or a facsimile of it, for witch hazel length and width of leaves for upper and lower branches. We've already conducted the correlation, and if you haven't already watched that podcast, you should before you watch this. And we've also conducted the regression, which you should also watch before you watch this. These are all up on YouTube now, and I've given you the links. Now we're going to do Anova. Okay, so I've made a tab here called Anova. It's empty at the moment, but I'm going to go to the Data tab. I'm going to select all the data, plus the mean and standard errors that we created before in the correlation podcast. I'm going to copy that. I'm going to go back to the Anova tab, which I've created and named. It used to be called Sheet 4. And I'm going to paste the data. Okay. So to do an Anova let's say we want to do an Anova and look at whether there's a difference in leaf width between upper and lower branches. Okay. We're going to have to rearrange this data a little bit. Okay. So we can create a new column called upper and another column called lower. And then we'll just transfer the width data from upper, just copy it, paste it, and the width data from lower. And now we have a setup for testing a single factor Anova for differences in leaf width between upper and lower branches for analysis in Excel. So let's go to the Data tab, Data Analysis, and as before, we'll just select the test we want, Anova single factor in this particular instance. Okay. Okay. The input range is much like selecting it for correlation. It's looking for a group of columns or a group of rows, depending on how we have it set up. Here we have it set up as two columns, so a group of columns. And that's why we have this as columns. Again, we're going to select the labels as well. Select the input range, upper and lower, all the data we have. And select the output range. I already have, but let's do it again. I'll just select J2 right next to the data. Okay. Everything else looks fine. Our alpha value, or the p-value that we'll accept as significant, is 0.05. That's a number has to be lower than that for it to reject the null hypothesis, and therefore for us to accept our positive hypothesis of a difference in leaf widths between upper and lower branches. And here's our analysis. And right away we see our p-value is larger than 0.05. And so what we find from the Anova analysis on this fake data, although yours will be real, is that there is no difference between upper and lower leaves for leaf width. May not be true for length. Length could be significant and width could not, or vice versa, or both could be insignificant or significant. We just don't know what to expect. Okay, so let's create a graph for this, which I failed miserably to do in lab today. But here, I think we'll be able to do it because I've practiced. Okay, so I'm going to insert a column figure. The first one under 2D column, the one all the way to the left. And it's going to come up as empty. Oh, excuse me. What did I have selected? Okay, select nothing. Okay, it's come up as empty. Now I can right click on this empty chart area and select data. Okay, and I'm going to add data. Right? What's the series name? We want two bars. We want one that shows the mean value and standard error for upper, and the mean value and standard error for lower leaf width in centimeters. Okay, so the series name, we'll just select upper, and the series value is the mean for upper width, which is here. Hit OK. Now we're going to add another one for lower. So the series name is lower. Series value is the mean for the width of leaves in lower, which is here. Hit OK. Okay, so we have our graph. We'll keep this because it tells us what the colors mean. And I'm not going to screw with the colors for now. We'll just keep this simple. But you could change these colors to white and gray or something like that. So I'm going to select the blue bar, which is the upper bar. I'm going to right-click and format the data series. Nope, that's not what I want to do. I want to go to Chart Tools Layout. Sorry, folks. Error bars. More error bar options. Okay. What we want is error bars that go above and below, just like you see here. It's already default selected to both. Okay. We don't want the standard error to be calculated by Excel. We want to put in our custom number. So we're going to say custom and specify value. Okay, and it's going to ask us to specify the value for the upper section of this bar and the lower section of this bar. So the positive error value is for upper width, this cell. Select a little square again. And the negative error value, it's the same cell. So just select that same cell again. Okay, and then hit OK. Okay. Select the red bar, which is lower. More error bar options. Custom. Specify value. Okay. And again, oh, it's just a bizzle. I just want this thing out of my way so that I can select it, of course. Okay. Specify value. The positive error value is the standard error for width lower. And then negative value is the same cell. Hit OK. Okay, and there we have our standard error bars. It looks like it should be significant, but it's not. Generally, if they're not overlapping, they're significant. It's close, but in this case, not significant. Okay. Let's just go a little further. Let's format this data series. Fill, solid fill. Let's make this one black. Okay, let's make this one white. Format data series. Fill, solid fill. Let's go with white. Okay, let's make this line also black. So border color, solid line. Let's make it black. There we go. Okay. Gray might be better here. That way we can see the error bar. There, now we can see the error bar clearly. Okay. And that plus appropriate labeling of the y-axis and the x-axis and the title should get you a good grade.